Welcome to Chemistry Simplified. Our topic for today is subatomic particles and valence electrons. So we'll be talking about protons, neutrons, and electrons. So let's begin with hydrogen. So let's bring out the periodic table. And hydrogen is located on the upper left corner in the periodic table. It's in group 1A and in period 1 or energy level 1. Hydrogen, the atomic number is 1, which is the same as the number of proton. Number of neutrons for hydrogen is 0. Why? Because the mass number is 1 and the number of proton is 1 as well. So the number of neutrons has to equal to 0 because we know that the mass number is equal to the number of proton plus the number of neutrons. This is a nucleus where we have 1 proton and 0 neutrons because we said hydrogen has no neutrons. Number of electrons is 1. And let's have a blue circle representing the number of electrons. So this is the first energy level. And on that energy level, we have only 1 electron because hydrogen only has 1 electron. So this electron represents the valence electron that is found in hydrogen. Now let's talk about helium. Again, we have the periodic table, and we see in the upper right corner, we see helium. Helium is in group 8A and period 1. Now, even though helium is in group 8A, it does not behave like the other elements that are in this period because helium only have 2 electrons. So this is helium. Its atomic number is 2, which is also the number of proton. And helium also has 2 neutrons because the mass number is 4. And the nucleus, we have the protons and the neutrons, 2 protons and 2 neutrons. And we have 2 electrons. Again, the blue circle represents electrons. Let's bring the energy level because n is equal to 1, so we only have 1 energy level. So this is 1 and 2 electrons for helium. So its valence electron is 2. So helium, even though it's a noble gas, it's in period 8, it only has 2 valence electrons. If you remember in our presentation, the periodic table, we said that helium was special because when we do electronic configuration, it looks as if helium is sitting next to hydrogen on the upper left corner instead of the upper right corner of the periodic table. Next, let's talk about lithium. There is lithium. It's in group 1A and in period 2, second energy level. Right? The atomic number is 3. That's also the number of proton. It has 4 neutrons because the mass number is 7. 7 minus 3 gives us 4 neutrons. So that's the nucleus with 3 protons and 4 neutrons. It has 3 electrons. First energy level has 2 electrons. The maximum number of electrons that we can have in the first energy level is only 2. When we talk about the quantum numbers, in quantum mechanics, we'll talk more about this. So we need to have a second energy level. Remember, lithium is in period 2, or the second energy level. And there is only 1 electron on that energy level because the total number of electrons is 3. So the first 2 electrons are located on the first energy level, and we need 1 more electron, and we place that electron in the second energy level. So therefore, lithium only has 1 valence electron. So the valence electrons are the electrons that are found in the outermost energy level. So the 2 electrons that are inside are called core electrons. They are not available for interaction or bonding. So that's why we said that lithium only has 1 valence electron. Next, let's look at magnesium. Magnesium is located in the second group, group 2A, and in period 3. The atomic number is 12, and that's also the number of protons, and the neutrons, number of neutrons is 12 as well. The mass number is 24. 24 minus 12 gives us 12. And this is a nucleus with the protons and the neutrons. There are 12 electrons as well because we have 12 protons. The first energy level, if you remember, can only have 2 electrons. So these are the first 2 electrons in the first energy level. The second energy level can hold a maximum number of 8 electrons. Now, the energy levels do not look like this. Only the first energy level look like a circle. The rest of them, they look different. But for simplicity, to make our life easy, we represent them as if they are circular with 8 electrons. But they don't look like this. Most textbooks, they don't show it that way. They used to in the past, but not anymore. Right, the second energy level with 8 electrons, so we have a total of 10 electrons so far. So we have to bring a third energy level, and that energy level, the third energy level, has 2 electrons. If you remember, we said the electrons in the outermost energy level, that's the valence electron. So we would say that magnesium has 2 valence electrons. It has a total of 12, but 10 of them are located on the inside. We call them core electrons. And the last 2 that are on the outermost energy level, we refer to them as valence electrons. Our last example is chlorine. Chlorine is in group 7A and in period 3, N is equal to 3, third energy level. So if you look here, the group 7A tells us that we expect chlorine to have 7 electrons. And N equal to 3, we expect chlorine to have 3 energy level. So let's look at that. Atomic number is 17, which is the number of protons as well. Number of neutrons is 18. 35, which is the mass number, minus 17, which is the atomic number. We get 18 for the number of neutrons. And this is a nucleus with 17 protons and 18 neutrons. We also have 17 electrons. This is the first energy level. We expect it to have 2 electrons. We'll bring another energy level. And that energy level should have 8 electrons because the maximum number of electrons that can be found in these energy level is 8. The first one can have a maximum number of 2. The second one can have a maximum number of 8. So we have 10 electrons so far. So we bring another energy level. Remember, chlorine is in period 3, so we expect to have 3 energy level. And in the third and last energy level, we should expect to have 7 electrons to make it a total of 17. So we have 7 electrons in the last energy level, and this is also the valence electrons for chlorine. So chlorine has 7 valence electrons. Valence electron is very important in terms of them being available for bonding, for reaction. So in future lecture, in the upcoming presentation we're going to have, we're going to show how does that happen. All right, so this is the end of our destination. We are done. Thank you for watching. Please remember to like, subscribe, and share. And let us know in the comment section if you had found our presentation to be useful. Have a great day.